Hello, students, all of you. You are welcome to my YouTube channel, Nepkim Guru. Nowadays, I'm going to discuss about the chapter 2, Ionic Equilibrium, class 12 chemistry. In Ionic Equilibrium chapter, I have already discussed about the Westphal dilution law and its related numericals, as well as I have described about the pH concept, pH and pH scale concept, and autoionization of water. In today's video, I'm going to describe about the numerical problems related to pH. Today I'm going to discuss a very simple type of numericals of pH. Once you get the knowledge of the simple type of pH, then you can easily build up your knowledge or more complex type of problems. So let us see at first the simple type of problem here, okay? Calculate the pH of 0.1 molar HCl. The first problem is calculate the pH of 0.1 molar HCl. So you know that HCl is acid and HCl ionizes as plus and Cl minus. So we have given there HCl molarity 0.1 molar. So when it ionizes, then it also gives 0.1 molar As plus and 0.1 molar Cl minus. So you can easily know that HCl is very strong electrolyte and it ionizes completely. So how much is the molarity of HCl? That is the molarity of H plus and Cl minus. So you can easily identify that the concentration of H plus in moles per liter or molarity is equals to 0.1 molar. Okay. And you know that what is the formula of pH? The formula of pH is equals to minus log H plus ion. So this is the formula, and to calculate pH you must know H plus value, but that H plus must be in molarity. Minus log H plus means 0.1. So you can easily find out the value here, pH value. So at the beginning I have discussed about the very simple problem, a typical problem how to calculate pH. So HCl, you can take HCl as an example. If you have 0.1 molar HCl, then you just find out S plus ion concentration at first. Because HCl is completely ionized and it gives 0.1 molar S plus. So concentration of S plus in moles per liter is 0.1 molar. And this S plus 0.1 molar value you can easily put in S plus value here. So the formula of pH is equals to minus log S plus ion, and you can easily put the value of S plus at 0.1, and you can calculate the pH of this solution. So this is the very first problem and very simple problem how to calculate pH of 0.1 molar HCl. So this is the first problem that I have discussed. Now in number 2, let us see number 2. Okay, in number 2 you have now problem calculate the pH of 0.1 molar NaOH. So you know NaOH is alkali or base. You know NaOH gives hydroxide ion, so you can easily ionize the NaOH into Na plus and OH minus. So what is the molarity of NaOH here? 0.1 molar NaOH we have. So 0.1 molar NaOH, when it completely ionizes, it gives 0.1 molar Na plus and 0.1 molar hydroxide. So here hydroxide ion concentration in moles per liter is equals to 0.1 molar. Friends, you can get pH value by two ways. One way, first way to calculate pH is you can find out first of all S plus ion concentration. As you know that ionic product of water S plus multiplied by hydroxide is equals to 10 to the power minus 14. Yes, that you know at 25 degrees centigrade. Let us assume that this problem is done in 25 degrees centigrade. So you can easily get S plus ion concentration by just dividing 10 to the power minus 14 with hydroxide ion concentration, that is 0.1. Okay, so in this way you can get it S plus ion concentration. And once you get S plus ion concentration, then pH equals to minus log S plus ion you can put there. 0.1 is 10 to the power minus 1, and that it goes upside. So 10 to the power minus 13, it will be I think 10 to the power minus 13. So pH equals to minus log S plus ion and minus log 10 to the power minus 13. Therefore pH is equals to 13 here. So you can calculate the pH of 0.1 molar NaOH in this way, and pH you get 13. Similarly, this pH will be 13 here. pH equals to 13, you can get it. So in this way you can calculate the pH for basic solution. This is what first way, and you can also solve it by second way. So let us see second way. In the second way, you can calculate first of all POS by putting there minus log hydroxide ion concentration, and minus log hydroxide ion concentration is equals to 0.1. So this is equals to 1. Now you have PS plus POH equals to 14, and you can get it PS equals to 14 minus POH, that is equals to 14 minus 1, which is equals to 13. In this way also you can calculate the PS value. So you have two ideas, okay. You can calculate PS of NaOH solution by two ways. So either you calculate it by that way or this way, no problem, you can calculate by any way. So if you have NaOH solution, if you have NaOH sodium hydroxide basic solution, then you get first of all hydroxide ion. Then by hydroxide ion you can get POH. Once you calculate POH, then by using this formula you can easily calculate pH subtracting from the 14 how much POH you get it. Okay, in this way you can solve the pH of basic solution. So this is the second number problem that I have discussed about how to calculate pH of basic solution. Okay, now I go to number third type of problem. So calculate the pH of now we have calculate the pH of 1 gram per liter NaOH solution. So this kind of problem also there may be, like calculate the pH of 1 gram per liter NaOH solution. So if you have gram per liter value, gram per liter is given there 1. So molarity you can calculate. Molarity equals to gram per liter divided by molecular mass of the molecular weight, that you can see. Gram per liter is 1 divided by molecular weight is 40. So this is the molarity value. So once you get molarity value, then you can ionize the NaOH into Na plus and OH minus. So NaOH molarity is 1 by 40 molar, and this will be also 1 by 40, and this will be also 1 by 40. Hydroxide ion concentration is 1 by 40 molar. So once you get hydroxide ion, then you can find out POH by minus log hydroxide ion is 1 by 40 molar. Then you can calculate the POH. Suppose if you get each X, then you can calculate pH by subtracting from 14 in this way, because pH plus POH will be 14, and you can subtract the POH from 14. So 14 minus X, that you get Y. So this is how to calculate pH of NaOH solution when gram per liter is given. So gram per liter must be converted into first of all molarity. Once you convert into molarity, then you can easily solve it how to calculate pH. So in this way you can calculate the pH of the NaOH solution when gram per liter is given. This is number third. Now I'm going to solve about number fourth type of problem. Today I'm going to solve about the very simple type of problems, starting problems, typical problems that you should start at first. So let us see number 4 problem. Okay, in number 4, calculate the pH of 0.1 molar H2SO4. So let us see here. We have H2SO4. Okay, H2SO4 means dibasic acid that when ionized it gives 2H plus sulfate ion. So you have 0.1 molar H2SO4. So when it ionizes, then it gives 0.1 into 2 molar H plus, and here, and 0.1 molar sulfate. So H plus ion concentration will be equals to 0.2 molar. So how do you calculate now pH? pH equals to minus log H plus ion concentration, and this you can put minus log 0.2 equals to what value you can get it, that is the pH of 0.1 molar H2SO4. So friends, when you talk about the H2SO4, then When you talk about the H2S4, then it ionizes and it gives 2S plus ion. So what is the molarity of H2S4? That 2 times you have to multiply it. So once you get S plus ion concentration in molarity, then you can easily put in the formula pH equals to minus log S plus ion, and you can calculate the pH. So this is the way how to solve this problem. This is number 4 problem. Okay, let us see number 5. Now we go to number 5 problem. In number 5, calculate the pH of solution. Calculate the pH of solution um, of 0.04 normal HNO3 nitric acid. So let us see here. It is nitric acid. Okay, nitric acid, when it ionizes, it gives purely S plus and nitrate ion. So we have in normality, so we cannot use normality directly, but I have already told you S plus ion concentration should be in molarity. So normality equals to molarity into basicity. So normality we have 0.04, and molarity we need to calculate. The basicity is 1 because HNO3 ionizes and it gives only one S plus, so basicity is 1. Molarity equals to 0.04 divided by 1, that is equals to 0.04. So what is the normality? Then molarity also same, therefore HNO3 molarity is given as 0.04 molar, and it also gives 0.04 molar as plus, and similarly 0.04 molar nitrate. So what is the pH now? pH equals to minus log hydrogen ion concentration, and that is equals to minus log S plus ion concentration is 0.04. So you can get it the value here. What is the pH value of this 0.04 normal HNO3? So in case of mono basic acid, you can easily say that normality equals to molarity. So what is the normality? Then molarity will be same, and that S plus value is also same here. So you can put it S plus value and you get it result. So this is the idea how to calculate pH of the solution of 0.04 molar HNO3. Now I go to number 6. Okay, finally. In number 6, calculate the pH of 0.01 normal H2SO4. So this kind of problem if we have, then H2S4, in case of H2S4 it is dibasic acid. H2S4 ionizes, it gives 2S plus plus sulfate ion. So we have normality equals to molarity into basicity, and we want to get molarity here. So normality is 0.01 equals to molarity into basicity is 2 here in case of H2SO4. So molarity equals to 0.01 divided by 2, that is equals to 0.01, 0.005. So this is the molarity of H2S4. So once you get molarity, this is 0.01 divided by 2 molar. So it will be giving a hydrogen ion 2 times 0.01 divided by 2. So it is 2 and 2 cut down, that 0.01 molar S plus ion. So what is the S plus ion concentration here? 0.01 molar. So now pH you can calculate. pH equals to minus log hydrogen ion, and it is equals to minus log 0.01. So minus log 0.01 value you can put there 10 to the power minus 2, and this will be equals to 2. So in this way you can easily calculate in case of H2SO4 and normality is given, don't be confused. Normality should be converted into molarity first, and then once you get molarity of H2SO4, then you get how much S plus ion. You just calculate it, molarity of S plus ion, and you put in the formula pH equals to minus log S plus ion. You easily get the pH value. So this is the way how do you calculate pH of the solution, okay, in different cases, in case of base or in case of acid. So this is type 1 problem where simply you can calculate pH, and this is very simple type of problem. Now let us see type 2 type of problem, okay. In the case of type 2 problem, calculate first problem is calculate S plus ion concentration if the solution has pH 9.5. So in this problem we'll be giving here pH. So once you have pH, then you have to calculate S plus ion, just reverse of the type 1 problem. So we have formula here, pH equals to minus log S plus. This is the formula. Now pH value is given there as 9.5, and minus log S plus ion. So you need to calculate S plus ion here. So this minus sign you just bring in this side. Minus 9.5 equals to log S plus. So S plus ion will be log in this in this side, it will be anti-log of minus 9.5. So what is the value of this anti-log of minus 9.5? That is the concentration of S plus in mole per liter. So in this way you can calculate the S plus ion. So in the calculator you can use anti-log value. Anti-log of minus 9.5, you just get it, and you get it S plus value. Okay. So in this way, when pH is given, then you can easily calculate S plus ion. So this is type 2 problem. Now I go to second problem of type 2, number 2. So in number 2, calculate hydroxide ion. Calculate hydroxide ion when the pH of solution is, pH of solution is 10. When pH is given as 10, you have to calculate the hydroxide ion. It is the base. pH equals to minus log hydrogen ion concentration. This is the formula. This is the basic formula. You have given there pH 10 minus log hydrogen ion concentration. You need to calculate it first. Though you need to calculate hydroxide, then you calculate first of all S plus ion. So S plus ion equals to minus anti-log of minus 10, anti-log minus 10. Then you can calculate the S plus ion concentration. That will be equals to, I think, 1 into 10 to the power minus 10. So once you get S plus, ionic product of water is S plus into hydroxide equals to 10 to the power minus 14. This is the ionic product value. I have already discussed in previous video. So S plus into hydroxide equals to 10 to the power minus 14. So you have S plus how much? 10 to the power minus 10 into hydroxide ion equals to 10 to the power minus 14. So what is hydroxide ion concentration here? This is 10 to the power minus 4. Therefore, this is 10 to the power minus 4 molar. This is the answer of hydroxide ion concentration. Okay. In this case, you just calculate first of all hydrogen ion concentration by just using the formula, and once you get hydrogen ion concentration, then you find out the hydroxide ion concentration by using the ionic product of water. Or you can solve it by another way, like you can get it POS equals to 14 minus PS first, and then 14 minus 10 you can do, and this 4, then POS will be equals to minus log hydroxide ion. Then you can directly use this formula to calculate hydroxide ion as well. So you can solve the problem by two ways. So friends, today I have discussed about the very simple problems related to pH, how to calculate pH of the solution, and how to calculate hydrogen ion concentration and hydroxide ion concentration from the problem where pH is given. So students, today I have discussed about very simple type of numerical problems related to pH. I hope that all of you watch this video and get the knowledge of how to calculate pH and how to calculate hydroxide ion concentration as well as ion concentration from the given data. So next time, in next video, I surely discuss about the little bit complex type of, little bit difficult type of problems related to pH. Up to that time, you subscribe my channel for new videos. Up to that time, let's say goodbye.